The next lab that we're going to be doing is basically titration. It's the lab number 15 right here. Okay, neutralization. So neutralization happens when acid and base react, forming salt and water with a pH of 0. So sodium hydroxide interacts with hydrochloric acid, forming salt, sodium chloride, and water. OH, the amount of OH combines in equal quantities with the amount of H. Okay. So salt is a compound that is positive ion other than hydrogen and negative ion other than hydroxide. So sodium chloride, sodium sulfite, sulfate, potassium chloride. So we're going to use titration to measure how much acid is present in the solution. We add, in our experiment, we're going to be adding base to the acidic solution, or you can add acid to the basic solution depending on what you're measuring. We already prepared the burette. I'm going to show you. So here you can see the burette, okay, and the Erlenmeyer flask with the vinegar with the universal indicator added. The burette contains sodium hydroxide right there. It's filled with sodium hydroxide. So we're going to start titrating soon. So now I'm going to start adding the sodium hydroxide drop by drop, periodically mixing. So you have to open it very, very, very slowly. And here we go. We're waiting for the solution to turn green, basically. You maybe can make it go a little bit faster, but still not pouring it directly down in the solution, drop by drop. So if you look at the color, we're getting closer to green. We're getting closer to the green. Probably a couple more drops here. So solution turned green throughout. Look, you a little bit over titrated, and the reading is, so we used 14.2. So we used 14.2 milliliters. Try it second time. I'm just draining some of this. Okay. So you will basically, the only thing that you need to do is to, what did you get? Actually it's 14. Because you count, so basically, oh no, 16.2, 16.2, right. So we checked, and it turns out I was incorrect. It was actually 16.2. Not 14.2. Okay, so 16.2 milliliters we used. And here we're going to have another try. gets much closer to the yellow. So we're going to make it slower. I'm getting very close to the green. So this time it's 15.9. milliliters this time. So we fill out this table. I basically told you it's going to be for trial 1 16.2, for trial 2 15.9, and then you calculate the molarity of the acid. So you know the volume of acid, which is 5 milliliters. You don't know the molarity of the acid, however, but you know the volume of base, which is 16.2 for trial 1 and 15.9 for trial 2. You know the molarity of the base, which is 0.2 molar, and then you just, so whatever the numbers are, you calculate the molarity of the acid. You calculate the average molarity of the acid, and then just write down molecular weight. Now, knowing the molarity and molecular weight, you can calculate the percent concentration by multiplying the molarity by the molecular weight by 0.1, and 0.1 is the conversion factor, 0.1%. So you will need to find that concentration.